Start recording. Okay, hopefully this records. Just give it another minute.
David. Hi, David.
All right, let's get started. Thank you guys for being back. This is the part 3, actually part 4 of the Applied Clean Code series. This is the third talk where we will try and see how to apply the content from talks 1 and 2. Just a quick note on the feedback. The feedback so far, in general, people have found the content helpful, so that's great. With regards to going forward, people were wondering, where and how we can put this to use in the day-to-day environment in our jobs. So that's an excellent feedback. And this talk and the subsequent hands-on should hopefully nicely dovetail into the day-to-day work that we do, and I'll take us through how. So there's a clear plan for that Rohan, myself, and Alistair we've sort of at least we have a plan. We'll see how far that goes. The other feedback is people have asked me to slow down. That has been a long-standing problem for me, so please feel free to interrupt me. The difference in accent also makes it worse, so by all means interrupt me. I tend to get excited on this material, so that doesn't help either. But yeah, so let's get rolling. So anybody know where the top left picture is from?
Is that Babbage's difference engine?
You may be right, but it's really, I don't know. It's from the book Legacy Code Refactoring by Michael Feathers. So it's just the cover of that. So you're probably right. I don't know. Yeah. Anyway, so what we will cover is principles, techniques, and demo. There are not much principles and not much techniques. It's essentially application of the stuff that we've known so far. The demo, I promise you, is going to be very interesting, right? And let's get started. So this is the same guy, a different cat. This is my other one, right? It's really more of a dog than a cat. But yeah, its name is Tim Tam. The agenda today, we'll quickly brush through. This is something that we will probably cover towards the end, but this is a high-level map of what I believe is software 1.0 core developer skills. We'll define what a legacy code is. It always is good to start with a definition. Then we'll define what a refactoring is. We'll take a general algorithm for a high-level algorithm that can be applied to any code base, any language, any framework, doesn't matter, right? A general algorithm for legacy code refactoring. Then we'll look at the tools and techniques that I have used in the past and that are mostly applicable in a .NET front-end-ish environment. And this is something that we already have in EDMI. There's nothing new here, especially with point number 5. And then finally a demo, right? So this one I want to spend a bit of time because this is going to be fun. And this is how we will plan to do things in the future as well. So this is essentially a high-level map. The green ones are the ones that we've covered. The red is something that we will cover today. and there are other bunch of stuff that make it more complete. This doesn't yet list down the individual patterns, individual frameworks, languages, right? Those, in my opinion, are transient. But what matters is getting really finger memory for these, like get into a problem and how do you apply the general LCR, legacy code refactoring, right? So that's the whole idea, um, right? The fourth circle from the outside is obviously the three top paradigms, right? Right. So we will, if necessary, we'll spend more time on this slide. The main thing is these skills are timeless. They will be applicable as long as software 1.0 is present, right? With software 2.0, we'll see what happens, but this has been around since 60s, 70s. This type of thinking. They're independent of languages, tools, and frameworks, right? And as one goes outwards, the complexity of the system increases, right? So where you finally get to a domain-driven design that can tackle systems of any scale, any complexity, right? The more sharper we are in the skill, the lesser contextual thinking required. So there is usually a way to get around and do stuff at each scope, right? Lesser is the stress, obviously, right? Nobody likes stress. We want our jobs to be fun, and then more fun it is to be a developer, right? Now, the way to get this is to get any other skill, practice, pair up, review sample code, look for mentors, right? So we will come back to this in detail if necessary, after the talk. So what is legacy code? Anybody want to take a crack at it?
I'll have a stab.
Sure.
It's code for which the tests are inadequate to allow us to safely modify it.
Yep, that's most of the definition, right? Code without tests or inadequate tests, but that also business depends on. So that's earning that's providing for your bread and butter today, right? So that's business critical code, but unfortunately they don't, for whatever reason, they do not have sufficient code coverage, right? What it is not. So this is where I have seen people in my previous teams confuse. It is not someone else's code. It is not ugly code, and it is not code violating any of the principles, right? So those are not what we define as legacy code. Now, a few points to note here. Again, this is something that I think we as developers, we already know this, but it just helps to kind of reinforce. So left to itself, right? As we discussed in the simple design, entropy is a measure of the system's disorder. It always increases, which essentially implies that all code eventually becomes legacy if left to itself, right? Which means the greenfield projects also become legacy code unless one knows how to continuously handle legacy code. So legacy code is, that's why I put it as one of the outermost diagrams, outermost shells. And of course, for people in general, I think this is a very nice social way to have fun with fellow developers and kindred spirits, right? This is really a lot of fun. Tackling a piece of code that was unwieldy in the beginning, and now now it looks great, behaves great, and has a lot of tests and is easy to change. Those things are always fun. So I would like to speak about a 16,000 lines of code that pretty much everybody using a computer on the planet uses. This is a Microsoft story, but it will take a while, so I'll keep that for the end. But this has been tackled using pretty much the same techniques that we're going to discuss. I haven't been a part of this. A mentor of mine drove this effort back at Microsoft, but we can talk about it down the line. The point being that the general algorithm that we will see, it really scales up very nicely. So what is refactoring? Anybody want to take a crack at defining refactoring? Let's see what it is. This is as per Martin Fowler, right? The guy who wrote the book on refactoring. It's essentially to restructure software by applying a series of changes without changing its observable behavior, right? So that's without changing its observable behavior is the key, right? Because if you're changing it, then you're either fixing a bug or you're adding a feature or you are probably causing some damage. But the key here is to not change its observable behavior. And observable to whom? It's a customer. At some level, depending on the business critical nature of the piece of code we are attempting to refactor, we may have to retain bug for bug compatibility. So if there's a bug here, we cannot say that, hey, it got fixed in the refactoring. So that very often in class libraries, for example, in the .NET Framework class libraries, when we originally published it back at Microsoft, there used to be bugs, for example, bugs in the C# compiler. And what had happened was customers had taken a dependency to write their applications on those bugs, right? So customers actually use that bugs to deliver features, which means that we just can't go around, fixing the bugs because we've suddenly broken the customer's code. It's again a very directed effort. We can always have fun, but it's usually best done as a directed effort to solve a very specific issue, right? So these are the smells or some solid violation or some dry violation, right? These are the going back to the first talk. Else call Yagni, typically. Yagni and get on with feature work. In general, success in refactoring in general is the lesser logic one understands. So lesser one avoids getting entangled into the business logic, the better it is for the refactoring, right? This is very counterintuitive, but I'll show us how. And of course, the more mechanical the process is, and when I say mechanical, using tools like T-Sharper or Visual Studio IDE or some of the provable refactorings, right? You just mechanically change the code, right? So more mechanical it is, more lends itself to provability. Now, with regards to refactoring, one of my mentors had a nice way to classify them, right? So with respect to changes, like, and what he recommends is typically when you do commits, you tag it with, F or like this tagging nomenclature. And what happens is when you're reviewing the code, then depending on the tag, your attention can vary. For example, F is a feature work, B is a bug, right? T, again, green, safe, it's a test only change. R, it's a provable refactoring. So you typically won't need to even review the code because they've either gone through the provable refactoring processes or they've used some tools. So you can just completely jump over that commit. A is automated. Again, this is automated formatting or automated refactoring or any of the automated tools that do the job for you. Or automated code generation as well, right? Some of those designer.cs files. And finally, we have a bang, bang, bang in a red. And this is basically I meant to refactor, but I fucked it up instead, right? So the reviewer needs to take a very close look, or when we send it for solution testing or when we send it for body testing, we need to take a very close look at it, right? So this is where the danger lies, right? So we want to be in the middle three, T, R, and A categories. When we are refactoring, obviously, we have to add features, obviously we have to fix bugs, and obviously there will be times where we have to edit the code, right? But the idea is that as long as we're in the T, R, and A categories, very minimal stress in the system. Okay, let's take a look at the general algorithm for legacy code refactoring. This has essentially been formalized by Michael Feathers in his book, Working Effectively with Legacy Code, right? But this I've added my own tweaks here depending on my experience. But the idea is that overall structure remains the same, and as in when you keep applying, you start sort of tweaking stuff. So first and foremost is isolate where you need to make the change, right? So you can't just start making the change, and this requires, actually, I'll describe each of the steps. Let's just go over the steps first. So isolate where you need to make the change. Here's the interesting part, right? Treat the area around the place where you isolate it as a long sheet of paper, right? Don't try and understand it. Identify seams. Anybody know what a seam is with regarding to legacy code? Just the order of events that should happen now. So it is a bit of a marker. Okay, we'll come to it. So identify seams. In short, seams are places in the code where you can change the behavior of the code without actually changing the code, right? So this is something we do all day, right? Pretty much. We may not know it with this name, but this is something that we continue doing. I'll come to this. Then we do something called write pinning tests or characterization tests. And these are the tests that essentially lock down the existing behavior of the piece of code we are trying to modify. And depending on how critical that code is, it will lock down even the bugs. So you will write a test for even a bug, and you will write a test for every logical flow, every code path, and depending on how severe it is, you will pay real attention. So this is where the crux of the thing is, right? So this is what is going to protect us. Then we apply provable refactorings to start with. This is, I'll come to it, what these are. Once the provable refactoring is done, with pinning tests, it becomes more or less wieldy. It starts lending itself to talk one, which is simple design, right? So this is where we identify smells and violations. We refactor, write unit tests, loop it, and at some point we call it EDMI, right? We're done. Let's take a look at each of the steps. So this is where we isolate the code to be changed. Again, this depends on our architecture, right? So this is where a person with a global view of the system will need to come and help you out, right? So we can't make it as a. So the thing is, even if you isolate in a wrong place, then you probably have caused more damage than you're trying to resolve. So this is very context dependent. This is very architecture dependent, and sometimes you may need to make the entire the code base open close principle compliant, for which you might have to go through this loop once anyway, right? So the demo that I will show, we will do exactly that. Now, again, treat it as a long sheet of paper means you don't want to be knowing the business logic, because there is no way for you to, you're not the processor, you're not the computer, so there's no way you can understand all the flows, all the scenarios, right? So best keep it mechanical, lesser thinking, right? So this might sound counterintuitive, but is actually the only way it works, right? Because the moment you start getting into the nitty-gritties, you are likely to make a mistake, right? So there was a saying in, I think this was Under Dark Territory, Under Siege. It's the Steven Seagal movie. The villain comes and says, "Assumption is the mother of all fuck-ups." So I think this is where it's applicable. So if you don't read it, if you don't understand it, you can't assume anything, right? This is points where behavior can change without code change. What would be an example of this? We do it every day. Any takers? So this is typically the place where we call into an external system, for example, through an interface, right? External system or an external library. And this is typically the point where you can supply an alternate implementation of the interface, and you've suddenly completely changed the behavior of the code, right? Without changing the code itself. Right, so that's a seam, right? And seams become powerful because now all of a sudden you can inject yourself in the flow of the code and see what's going on, right? You can see the values, you can pass in new values and things like that. And mocks are an example of that. So, you can control the flow using mocks. Again, write pinning tests. So there are various techniques. We will go through 3 techniques today. And of course, and this requires, again, a lot of practice, pairing up, learning, this is general, this is where, this is an art form, essentially. These are automated refactorings. They are provably safe. You can prove that the code that was before the refactoring is bug for bug compatible with the code after the refactoring. You can prove it, right? And when I say prove it, it's more of a mathematical proof, not a discussion proof. They are essentially 6 core refactorings. Most of the work can be done with them, but there are of course others, and we will take a look at 3 core refactorings and one fairly sexy refactoring. Um, then the next step is, again, this is going back to slide talk one, which is essentially make everything dry, right? And of course, along the way, you will figure out smells and apply solid and things like that. At this point, you can start taking more risks because the code starts lending itself to refactorability. So here at this point of time, depending on how safe the code looks, you can start kind of editing the code, right? But still, again, this is judgment, right? You have to make a lot of mistakes before like with anything else, before your judgment really builds up. I think I missed a step. Anyway, so once you refactor, you write more unit tests, and this becomes granular unit test. They test, they are not even long range integration tests. They are short range or unit test. And after a point, you just say Yagnik, so we can get on feature work, because the whole idea of this is to make the code base wieldy for us to be able to move fast, right? So that's the whole point of all this. So there is a business value behind this. There's a lot of fun as well, but the target is making money. There are some attributes that one typically requires for this process. So number one is patience, and a lot of patience. Number two is listen to the code, right? So there'll be signs, there'll be symptoms, there'll be smells, just listen. And finally, be gentle, right? Try not pushing your ideas of how the code should look like. Let it evolve, right? Where else do we apply these 3 characteristics? These 3 is another particular situation in life where we bring these characteristics.
Parenting.
Yes, I had something more spicy, but yes, parenting. Anybody else? Where else do we apply these 3? Do we bring to table these 3 characteristics? Well, you're taking somebody out on a date. It's as simple as that, right? Uh, so yeah, you could technically look at the refactoring exercise as taking the code base out on a date, right? It actually works pretty well that way, right? If that's the mindset. Then in that case, you're in less hurry to get things done and more hurry to see how things evolve, right? But we shall not digress. These are the common tools and techniques. These are standard for a typical .NET front-endish environment, and I'm sure, unfortunately, I lack knowledge in the Java environment, but we have like really good people around here who know both, like Stephen and David. They can fill in stuff that they have done corresponding to some of these. So first thing is characterization tests some of the techniques, right? And everything in green that comes up is something that we will see in the demo, right? So something called approval testing. Let's just quickly jump over this since it's green. We're going to show it, and I will not discuss it here, so that I'm eager to get onto the demo, right? So there are techniques for writing characterization tests, approval test. You use code coverage analysis, you use mutation testing, and you're trying to be opportunist. Like any opportunity to write a test, a characterization test, you take it with both hands. Anyone has used mutation testing earlier? It's actually a lot of fun. So we'll see how it is. Then provable refactorings, right? So there's some really lot of good work going on, right? So mostly need Arlo is, I'm proud to say, he's one of my mentors. He has core 6 refactorings. He has a blog, and he really sort of looks very deeply into these things. So mainly the core 6 are rename variable, rename method, rename class, whatever, inline variable, inline method, extract method, introduce local variable, introduce parameters, introduce field. This is something that we do on a daily basis, right? But essentially, Arlo's point is, if you have mastered these core 6, this is pretty much what you need to do to get your code base in a wieldy state, right, where you can And interestingly, these are also provable. Like most of this is already automated, like with ReSharper, and a lot of this is in Visual Studio 2019 and 2017 as well. But even if they're not automated, Arlo has a repository where he actually lists down steps, where if you follow those steps, these refactorings happen, and each step is provable, right? So you can prove, like, you can prove rigorously, you can prove that the code before and after is the same, bug for bug compatible. There are other refactoring techniques, provable refactoring. For example, lift conditional, we'll see something. It's actually pretty cute, right? Then there's this Git notation which I introduced earlier, which is that F, B, T, R, A, and bang, bang, bang. Then mocks. Mocks are an excellent tool to start legacy code refactoring, because using mocks, you can introduce as many seams at as many places you want. But again, mocks create an illusion of decoupling, right? So they don't really decouple, right? And therefore they're a smell. And therefore, eventually, our aim should be to get rid of as many mocks as possible, right? Not all of them, but as many. And finally, the IDE, right? So ReSharper is great. There are a lot of refactoring. Some of this core refactorings and a lot more of the refactorings are just automated, right? Things like auto formatting in an IDE. Live unit testing is a killer feature, right? It just removes a lot of stress, right? And of course, here expertise in other paradigms helps. Like functional programming is, in my opinion, very critical. Some of these techniques here, right? So we'll look at one of those things. But functional programming brings to the table a whole host of fairly counterintuitive techniques, right? So, and then finally pair programming, right? So pair programming, mobbing, or dojos, etc. They make it, it's really a social thing, right? So you don't need to be a loner in fighter battles. People, and it's usually learning happens very fast in pairing, or other social mechanisms. Now we'll go through a demo, hopefully. The demo is simple. So it's a demo of the LCR algorithm, like the boxes that I showed earlier and the flowchart that I showed earlier. So given an inventory management system, handle a new inventory item. Very simple. But you're going to have to do it in the Gilded Rose code base, right? So this is, I'll show us what it is. It's pretty infamous. Well, not that infamous. I mean, we've all seen code like this. Right, and remember, katas is a martial arts term, right? So once you repeat a kata, twice you repeat a kata, right? You can't help but start doing the same thing in your day-to-day thing, right? So this, for folks who haven't tried katas, I strongly recommend that you try it out, so that there's a magic to be seen, right? So same stuff. So let's get on with the demo. I'm going to open the code base. Just a minute. Okay, so so this is a quick tour of the code base first. So program.cs, let me just 150. Oh, thanks. So this is program.cs. This is just, I guess they're just trying to show how to use it, but this is not the fun part. This isn't the fun part either. So this is a class item. The constraint here is that you cannot touch this class, because this is maintained by a maniac who's going to come and shoot you literally if you touch this class. So this class is off bounds. Program is also off bounds as well, because I believe the business depends on this. Whatever. This is the code that we'll try and refactor. And what we are supposed to do is, if you see, these aged brie, backstage passes, etc., are all inventory items. And we were supposed to handle another inventory item, right? The rules of the game are somewhat like this, right? So there are some rules regarding quality update and and quality of each of the inventory items. But the new change to the system is that there's a new item called conjured, and it has a change in quality particular business logic, and we need to go make that make change to that piece of code. Right, we can read this up. I mean, this is fairly simple, but the whole point is we need to add another case here, right? So there's already 4 cases. Yeah, so this can affectionately be called as a clusterfuck, right? So um, yeah, this is fun. This is where the fun begins. Okay, so what do we do first? Okay, we isolate, right? So isolate where we need to make the change. It has to be obviously in this method, right? We have to handle another case, and we need to make this method open closed. So right now it's violating SRP. Right now it's violating OCP, as in normally I guess whoever wrote this code earlier would have probably added another case, another nested set of cases, and God knows what they would have done. But the whole idea is that what we're going to try and do is we're going to try and isolate the logic for each of this inventory item so that we can have another case statement or another block of code that handles only for the conjured items and not for any of this. Right now, if you see, they're all mixed up. Like, for example, in case it's not aged brie, which means it could be any of the other 3. And then inside that, it's fairly fucked up. Right, check this out. Right. Okay, so first and foremost, like, let's see what are the tests in the system, right? So it looks like there is some test, and let's run it. With any luck, we will have some getting started point. All right, looks like whoever wrote this test didn't bother. Okay, let's fix it. Slow steps, incremental steps, but they'll get us the result we want. Okay, now, so this is all well and good, but remember that we're not checking the quality of the item here, we're not checking the sell-in, and we're not checking other cases, right? So this test is fairly useless. So what we'll do is we'll introduce a new technique. This is, well, new as in we'll introduce a technique into the code base, which is called approval testing, and this is what it looks like, right? So just bear with me here. Approvals dot verify. What's the fun? ToString, right? So ToString has all 3 listed in it, right? So we can essentially sense the state of the object with ToString. Now what happens here if we run this? This is really smart. I mean, the smart technique. Okay, wait, we're still not done. So we need to add something called a differ, a reporter. Let's do that. So this is the reporter that the approval test is going to use to do its magic. Has anybody on the call used, or here, has anybody used approval test before? Okay, it's actually fun. So watch. Running the test, and what it does is it essentially captures the ToString here and writes it in a file called approve.txt. And what you do is, this is called the golden master, and you check it in with your code base, right? So this is essentially what is locking your code base into place. So what I'm going to do is so received is what is the output of the test, and approved is what was checked in earlier. So if you had committed a bug or if you have created a bug, these 2 are going to differ. And right now they're differing simply because this is the first time we're doing it. So I'm going to copy this over and update the golden master, check it in. Look, it created it here, right? So you can check in this code. Right, and now what happens is that it'll obviously pass because the items hasn't changed. Right, now we don't need this foo because now this is a stronger test for. So this is not only a test for foo but also the sell-in and the quality. Right, so what we'll do is we'll just remove this. We don't need this anymore. Right, and since we already have a test, we'll do a minor cleanup. Okay, so this is all well and good, but remember that code base has multiple conditionals, multiple conditions, and that has at least 3 inventory items. So we need to be able to feed in other stuff as well. So if the name is sulfurous, if the name is backstage passes with certain combination of selin and quality, what happens, right? So what we'll get in is a bit more powerful version of this approval called the combination approvals, which is essentially you give it a list of approvals and it runs all of them and does the same thing, same magic. So we'll just refactor in, right? So let's just generalize some of these things so that we don't hard code them. So my bad. Right, and so just bear with me a minute. I'm just generalizing this code, right? I'm going to refactor it out into a separate method, extract method. Okay, and I'm going to refactor this out into item string. Okay, so now this code is fairly generic. What we're going to say is we're going to say do update quality. Okay, so this is fine. Test should pass. We haven't done anything. I mean, I haven't written any line of code. I'm just refactoring. Now what we will do is we'll bring in something called combinations approval. Oops, my bad. And verify all combinations. But here it does an interesting thing. It will take a method that it will run with a set of parameters with the choices for each of the three parameters, right? So let's say that we have name, right, corresponding to parameter 1 of do update quality. Then we have selin, and then we have quality, right? So now what it will do is it will essentially run this method with every permutation combination of these from this set, right? So name, selin, and quality, name 2, selin 1, quality 1, like that. So all combinations will run. Now if you do this, what happens? Okay, watch. So the received has been updated, but the right hand side of the received hasn't really changed, simply because we haven't changed the test data. Left hand side, on the other hand, it just gives it a nice name, right? Remember that this line stands for a line of test, so therefore, so we can refer to it easily down the line. It just says for foo 00, and this is really a string, doesn't matter, but what matters is this, right? So we just copied it over, save it, right? And at this point the rest should be green. Excellent. We'll just rename these things, inline these things. So these are some of the techniques that we will use going down the line in the team-wide dojos, right? So we will try and identify a block of code during the sprint. And Rohan mentioned that there's going to be a sort of a lunch kind of a thing where we get together. So this is one of the things that we'll try and practice at that point, right? So these are the very techniques that we will use there. So this is how the rubber is going to meet the road, if you will. So I inlined all of them. I don't need this anymore because it's doing nothing. And I have a nice way to feed in more parameters here, more combinations of parameters, right? So just make sure the test is fine. So all well and good. Now, what are the other tests that we can write, right? So this is where we have to be opportunistic, right? So we'll use three techniques. One is code coverage based, another is general analysis with a partner, pairing partner, or a group, and the third one is mutation testing, right? So let's just run this for code coverage. Again, code coverage is a handy tool, but it's not to be overutilized. We know it. 100 code cover, simply because 100% code coverage does not imply anything. But it's an indication saying that, hey, you've covered some of the cases at least. So as expected, update quality method is just 36% coverage. Colors aren't clear, but the violet ones are the partially covered lines, the blue ones are the fully covered lines, and the yellow ones are the lines that are not covered, right? Now remember that we care about the quality because that's the output of the program that we care, right? So what we'll do is we'll straight away add cases for the inventory items. That's nothing, I mean, that should have been done, I guess, right up front. We don't need any techniques for that. So I'm going to just put cases for each of this. backstage pass. So this is where the patience aspect comes, right? So this is right. Remember that the more critical this piece of code is, the more sort of care you need to take, right? Because you mess up one of these cases, your business is going to get affected, right? So I think we have all three here, and the fourth one because this is already a test, so that's great. Now, how does the approval test work once this update has been done? So check this out. It added combinations for each of these new, new parameter values that we have passed. So 0, 0 is the only parameter values for the second and third parameters, but for parameter 1 we have 4 combinations. So so we'll just update our golden master with this, and as far as these combinations go, we're safe, right? Okay, so what else can we spot? What are the most obvious things we can straight away add in? So let's check for parameter number 2, right? So there is a cell in less than 0 condition, so let's just add a condition for that, right? And then cell in, so less than 0, then there is, I'm guessing, let's add, so there are some positive values for cell in. Let's just add I don't know, let's add 11 here, because 11 seems to be a good value here, right? What do we do for quality? So quality, there's a 50, there's a greater than 0, so let's just add values, and this is very cheap, right? So with every test, you're essentially blowing up the number. With every value you add to one of this, you're essentially increasing the number of tests, by orders of magnitudes, right? Order m into n into, right? So we have 1 here, which is greater than 0. Let's add another one for 50, and it says less than 50, so let's just do a 49 as well, right? And let's see what happens to the approval test. Okay, so it just added so now we have how many tests? We have 48 tests, right? So it took a combination, and remember, we haven't changed the code, so whatever code we got handed over, whatever code the business is currently depending on, this is the state of the code, right? Which means that we are locking down, right? Slowly but surely, we're locking down the behavior of the code with each of these tests. Update the golden master, commit it, right? And the test should be fine now. Right, so we can try out the code coverage, but code coverage is going to be 100% with this. So again, it doesn't yield anything much, right? So if test is updated, I'm going to delete this coloring scheme, right? And let's switch on to mutation testing. Right, for this we will switch on live unit testing, because live unit testing is really the killer feature that helps out with. So live unit testing is where you can actually make the IDE go faster than you. So literally faster than you. Now, if you don't do a quiet reporter, what will happen is when live unit testing runs, it will keep throwing that on your face. So just keep it quiet. So it will fail, but it will not throw up that the differ. And I'm going to switch on live unit testing. So watch. So all green and everything. So now let's try out something called a mutation testing, right? So mutation testing, what it does is you mutate values, targeted values. So for example, you mutate this to 2 and see what happens, right? If there was a test covering this, as in this case, it failed, right? So we can say that the mutant has been killed, right? So we're safe. So this particular path or this particular scenario has been taken care of by existing tests. Okay, so nothing new we have identified. So we go back, everything becomes green. Watch the tests here. So this is where it's most important, right? So let's try and update something. We don't need this such a big size for this. Let's try and update this, mutate this. Watch, we modified this, nothing failed. So this is called as the mutant survive, right? And you don't want the mutants to survive with your test suite, right? So this is one mutant that had survived. Let's just go back. Okay, you don't want to check in your mutants. Your product owner is going to come after you. Let's see. I think then this survives as well. So there's a problem here. So we don't have coverage, enough coverage for this. Coverage is in test scenario coverage, not code coverage. Right. So the selin is less than 11, selin is less than 6. Maybe we ought to add two values corresponding to them. So less than 6 is 5, less than 6 is less than 11 is 6, right? Let's just update our golden master, because it will fail now simply because the golden master is out of date. So what happens to the golden master? Let's see. So which means we've added, check this out, we've added 5, 6, 11, -1, all these things we've added here. So let's just update it. So we have some more coverage now based on mutation testing. Right. I'm going to go back to, oops, did that get thrown into my face? No. Okay. So everything is run. So we still haven't started refactoring simply because we can't refactor, just because we don't know what the behavior is, the code. So we're trying to lock down the behavior still at this point, right? So this is great. We covered two new scenarios. Now let's just make sure that the mutants are actually getting killed. Okay, now it is getting killed. So we have reasonable coverage. It's getting killed. Good news. Is there anything else? Let's just, we can try. And this is where the creativity, this is where pair programming helps. This is where more than one person, more than one brain working together usually yields good results. Okay, so the good, I think we'll leave it at this, right? Again, as we discover. Yeah. Okay. Here we go. Right. So this is sufficient coverage, I would think. Right. If you guys can spot something else, we can add that as well. But let's just move on. Right. This, I think, is good enough for this. Are there any other tests we can write? Let's take a look at the code base. So there is one particular file that has some output, right? So again, we're trying to be opportunists. So we'll try and capture this as well in a test. So again, this is a program.cs, so it has some going to the console and things like that, but this is a good test as well, right? Since business depends on it, let's just lock it in as well. So what we'll do is we'll do a similar approval testing for this, right? But this becomes a bit, this is where creativity comes in, right? And remember, we're not trying to fix program.cs. We will not refactor it simply because we're not in a state to refactor. So we have to do whatever we have to do without any refactoring, right? So watch some of the very creative techniques people have come out with. So clearly, this is not the test we want, right? So this new code, this is a template. So here, what we essentially have to do is program dot main. We want to run it and we want to capture what's happening, right? And simply because to the next step. So program, the args is not getting used, so we don't care. We could have also passed in a null, nobody would have cared. But the idea is that we want to be able to run this, but then we don't have a handle. So we don't have, the console is a good seam, but we don't have a handle in the seam yet. So we'll try and get control over that seam, the console seam, right? So how do you do that? We redirect the input and output, right? Simply, it's like old .NET trick, right? So new var s string reader, which will be the console in, string reader. This is actually very creative. People are very creative in general. That's a summary. /n. I'll come to why I'm adding that, right? So you can actually take a guess when the console application is done. It will ask for a key to be pressed and enter to be pressed. So this is what it's simulating. Now var sw equal to new string writer. And this is going to be the redirected console output. So we're going to try and feed it into a string builder. Right, generate local fake output. Well, we don't want a provider. What we want is a par, and what we want is a new string. Right, so this is just, we're trying to be opportunists and we're trying to write as many tests as we can before we get down to the fun, right? So again, so this is good, right? So the test is passing simply because it's not testing anything, right? Now we'll redirect the console. So right? Console dot set in is going to be sr, set out is going to be sw string writer, right? So whatever is happening in the console will now get redirected from and to these things. Okay, so now we have a handle on the seam, so we can sense the behavior of the code. Michael Feathers is a genius, in short, right? He's the one who formalized all of these, right? And so what do? Again, we pull in our approvals dot verify what? What do we verify here? The output. Whatever is the console output, we just verify that, right? It failed. Let's watch what happens when we run with the diff reporter. So diff reporter gives a nice watch. Nice. So this is essentially, at least these are some of these current test cases, right? So we have a bit more coverage, right? Because we know business depends on program.cs. So we're just being opportunist and capturing that as well as a test, right? So this is additional guarantee. We've printed this as well. Great, it's there, so it's there. Let's just, so no line of code changes without us knowing, or no line of code changes inadvertently, right? Run this again, and we're green. Ignore this because this is live unit testing. For some reason doesn't keep in sync with the other thing, so I don't know what. I think it's a bug in their code. So now what we will do is we shall turn back on live unit testing simply because our tests are done. There's nothing, there's no more. I mean, we can find out, but I think sufficient for purposes of refactoring, right? So we have all green. We're going to just shut down all the test windows. We're not. My bad. Hang on. So we're going to all shut down the test windows because we don't need the tests anymore. Test will be running in the background. Sorry. Yeah. So I've closed all the test .test files, and our test is going to be monitored by live unit testing. So we'll just keep an eye on this. Anytime it goes red, we're in trouble, right? And since we're refactoring, they should not go red across more than 2 or 3 key presses, right? So that's the whole idea, right? We're not going to touch program.cs. We're going to restrict into this. All right. So this is where the fun starts, right? So the first goal, so the eventual goal is to be able to add another inventory item and do its update, double as fast and whatever was given in the spec, right? For that purpose, we will try and make this open closed, this method. And by open closed, I mean while this method is going to be open for extension, namely adding another case, it will be closed for modification. We won't have to modify it, right? So first and foremost, let's just do some basic refactoring. So, item, and let's just pull this out into a separate method, right? Because it's logically one single method. So this is going to be update for. Okay, watch the tests. They should be green all the time. And here, here indication is that they're still running. This is what the circle means, and now they've gone green, right? Okay, so this is good. This is unnecessary, so we're going to inline it. Great. Okay, slightly better, but not there yet, right? So this is where lift conditionals. It's pretty sexy. Let's see how it works, right? So what we're going to do is we're going to apply approvable refactoring and tell me. I respectfully challenge you to tell me why this is not approvable refactoring. So what I'm going to do is I'm going to extract this method into some temporary random method, and I'm going to put a condition here. Watch, if else, right? Just added an if else, added this condition, right? And I'm going to move this into both blocks. So watch this, the test is ahead of me. So this is where the fun is, right? So anybody think this is not a provable refactoring? Anybody has any doubts that this is not a provable refactoring? So there are only two cases, and for both cases we're running the same code. So if at all we've created a bit more of a dead code, but there is no code we have changed as such, right? So now the next step is we're going to just inline this. So if it was resharper, I think resharper is an inline method, but unfortunately I don't have resharper. It's too pricey. I'm not going to buy it. I think I like live unit testing better, so I'm paying MSD instead. Right. So what I'm going to do is I'm going to just copy paste this code. I'm going to inline it, manually inline it. Bam, bam. Again, this is provable. So there's nothing, you can rigorously prove it. Again, everything is green, so we're good. Now what's the fun, right? So this is, we're doing a lift conditional. The idea is to be able to lift out each of these conditionals on their own, right? Now here, what is happening is, let's switch the order here. Let's invert the if. So let's start with something is aged brie first. Now here, watch, this is dead code, right? And the reason for that is we've already entered a condition where the item name is aged brie, but here we're checking item name is not aged brie. So this is false by definition, and false and anything else is just false, right? Okay, note that we're not trying to understand the logic here at all. We're not trying to understand who's doing what, in what cases what is happening, and nothing, right? We're going very mechanically. And since this is false, we can nuke unreachable code. Let's flip the order, which means now we just have an if true, which means the entire condition is just that. So what we've done is we've gotten rid of aged brie from that block, right? Now watch this. So this item is already aged brie, but here there's a condition called equals to something else. So clearly this is false, as indicated by the dead code here, right? So what we're going to do is we're just going to say false. This is fine, and I'm putting it false so that my ID knows. I think ReSharper has a way to do this automatically. What's the tests? They're green. We don't care anymore. Now item name is not equal to sulfurous, obviously, because it's aged brie. So this is true, and since this is true, the entire condition is, entire block is that, right? Wait for the test. Green. Item name is aged brie, and item name is not equal to aged brie. So by definition false. Nuke the code, flip the code, and this entire condition is, entire block is this. So if else is superfluous here. Okay, so we gotten rid of aged brie from this block. Now this else block is the case where item is not aged brie. Okay, so clearly item is not aged brie, so this is true. True and anything is true. Doesn't matter anymore, right? So aged brie is gone from here. Aged brie is gone completely. Oh no, we have one aged brie here. Okay, now we're this entire block where it's aged brie, so this is by definition true. Okay, and there is dead code here. We're going to nuke it. So this entire block becomes, we are not editing any code, we're not trying to understand any code here, we're going mechanically, right? And having the test watch over us. These are the pinning tests. So check this out, there are 80 or 100 odd tests that are finishing in 150 milliseconds, right? So that's the powerful aspect of it, right? So is there anywhere else there is aged brie? Nope. So now what we have done is we have isolated the condition aged brie and all logic related to aged brie using lift conditionals, right? So let's repeat this for backstage passes. Again, mechanical, dumb, very dumb, right? No thinking. Thinking is there. One of our virtues is being a lazy, right? I think I noticed it here. I think so. I think I'm just using that virtue. One of the virtues that we recommend EDMI developers have is, I think, is the laziness. There are two more things I forget right now, but anyways, I digress. So again, it's the same thing here. I'm going to do the same thing. If something, then do that thing, else do that thing, and I'm going to cut and paste. This is a provable refactoring, right? same block of code. And here what is going to happen is I'm going to just take this condition here and put it here, right? Test should be green, wait for them. Okay, great. I'm just going to flip it so that we have not equals instead we have equals. So invert if shouldn't matter because it's same for both cases, right? Now what I'm going to do is I'm going to just I wish I had resharper. Nuke it. We don't need this. Paste it here. Paste it here. So again, worst case we've created dead code, but there is no logic we have changed at all, right? We have just blindly gone. Okay, so how does this look? So item name is backstage passes, but here item name is not equals backstage passes. So clearly this is false, as indicated by the dead code. So we're going to kill this dead code. We're going to flip the conditional to see what actually we're doing here, and then we're going to take this and replace that entire if else with this, right? It's beautiful, it's evolving, it's emerging, right? Right. Again, item name is backstage pass. Item name is obviously backstage pass, so this is true, which means the entire condition becomes this. So watch this, right? The test is watching over me here, so that's where the fun is, right? So every time there's a green, I get a dopamine rush. So sort of kind of it's very addictive. Anyway, so item name is backstage passes. Any doubts so far? Anybody? Like, is this fun? Is it boring? Anybody on the call? Maybe they've turned off their mic. Okay.
I thought Ashton was talking, but he was in another meeting.
Okay, no worries. Okay, so bear with me. So again, so item name is not equal to sulfurous, which is the case here. So this is true simply because item name is a backstage passes. So therefore we replace this with. So we're slowly getting rid of this conditions if you see, right? Again, item name, check this out, dead code. So we do a false here. I think there's about 10 more minutes to go. I think we're running a bit late. So remove dead code here, flip the conditional, switch it, and we are good here. So this else condition is for what? Else condition is not backstage passes. So this is clearly true. Right, I'm going to go a bit fast here. So since this is true, this is going to be dead, and this is. So if you notice, the ID is also automatically formatting the code, so that also helps, right? And item name is not equal to sulfurous. We can't say that, right? We're not handling the sulfurous case yet. We're only handling backstage. So item name is not sulfurous. Leave it as it is. Again, item name is not backstage passes. We know that because we're in that particular case. So this is true. There's that code here. Nuke it, replace it, and there is no more backstage passes anywhere else but in this line. Okay, let's bear with me, and there'll be an interesting twist of events here. Watch. So this is where intuitively people when we read the code, developers go wrong, because what is going to come up is very counterintuitive. So what I'm going to do is I'm going to just say x, since this is small enough, if okay, so what we're doing is a sulfurous case now. Okay, and I'm going to just flip the condition just so that we handle it. Okay, so that's good. Now what's the fun? This is dead code. Okay, so I'm going to nuke it, and since this is an empty conditional, I'm going to nuke this as well. This is dead code, empty if, nuke it. Dead code, irrelevant, irrelevant, irrelevant. So basically there's no code handling sulfurous at all, right? So which means here this is true, so this is replaced with the entire block. This is true, replace with the entire block, and this is true, we replace with the entire block. So now this is all of a sudden, watch, let's just do a bit more of cleaning up. We're almost there. More of a cleaning up.
Sorry.
Okay, so oops, I did some mess up. Get back to green. Okay, we're in green. So this, this, I'm just trying to collapse them into a else if block. Okay. What the hell is happening? Oh, my bad, my bad. Go back, go back. I deleted the wrong one. Go back. Okay, so this is green. So let's do systematically, right? So this and this can go. Okay. This and this can go. There should be green now. Yes, there is. Right. So else if, save it. Okay. So great. We have now this is starting to become open close, right? So there's still a couple of more steps to go. I want to introduce dictionary based programming here as well. It's a functional programming technique. So what I'm going to do is we're going to pull out a method here which is called update quality for algebra. Okay, and similarly, so there are no more conditionals inside, at least with respect to the items. So as a result, for the new conjured items, we can have a different block altogether. But again, this is violating single responsibility principle because this method has too many reasons to change, and it is also violating OCP, right? Open close principle. So what we're going to do is update for process, right? Let's just add another one. Do sorry, update just to be consistent. Update quality for sulfurous item. We'll have to generate this method, right? And then we can move on. It failed because of this. So this is an empty method because it did nothing originally. And finally, we'll have another method called for all else, right? So this is starting to look a bit more open close, but still not. So we'll introduce something called a dictionary based private pick read only I read only dictionary string. What's the fun here? Action item. This is data map equals new bang. Okay, so essentially it's a map of string, which is the item name, and its updater method, right? So how do we fill in that? We fill it in from here, right? So this is how, if else cases is essentially a dictionary somewhere. So what we're going to do is we're going to take this, put it here. Just watch. This is very mechanical. There's no thinking going on here. Not much thinking going on here. Right. So this is the first item in the dictionary. Then second item in the dictionary similarly will be that function. This is technically not functional programming because it's mutating its arguments. It's not a pure function. So, but yeah, we're heading that way. More functional than it was before. Equals the third one, which is hopefully it will compile now. Excellent. So now we have a map with the names and their respective update methods. So what we can do here is now it's just plain old dictionary contains key item dot name, then do something which is none of this, but map of item.name. Again, this is returning an action. So this is fetching an action. We execute that action with item. Right. So everything is green. Each of these functions has only one reason to change, and therefore is SRP compliant. And finally, there's one small tiny area where OCP has been violated. This can be moved into a separate file, and we can add another one for, another case for what the spec is. Conjured, update quality for, right? Generate method, update quality for conjured. Beautiful. So we're done. This is pretty much what. Right. So now it's fairly easy. We can just add the condition here, whatever they need us to do. Business owner needs us to do. We can just, we just change only this piece of code, right? And we've gone through this entire refactoring exercise. This is a very powerful kata, and eventually, if you do it a few times, right, you will get the hang of it, and eventually, like, your brain will start operating this way. You can't help but do it in day-to-day code base. That upcoming hands-on session will be for you to simply repeat this. I have the videos. I'll have the videos ready. I have a sample repository which each of the steps committed. So you can, if necessary, you can just, copy paste stuff. But take yourselves through this, right? Take yourselves through this experience, right? But the demo is done, right? Hopefully this indicated this entire set of steps, right? So what's the key takeaways, right? So key takeaways are the algorithm for LCR, most of which we have followed now. Build a mental repository of decoupling and refactoring techniques. We've seen a few, right? Again, patience, listen, be gentle with the code base, right? So we were very systematic, very methodical. We did not bother understanding the code. Instead, we went it with known techniques. The next steps is going to be we're going to organize dojos, team-wide dojos. Like each feature team, we're going to identify a particular piece of code that we want refactored similarly, right? So that it's the piece of code something that is not letting us achieve velocity. I've seen a few in the libraries. We can start with those, and then every team is going to we're going to try and work this out, right? First, we'll start off experimenting, but eventually, I am very sure that we will have some commits that we can deploy to production, right? Following the same sort of things. Again, so same thing that I repeated, right? There'll be a champion for each of the teams. I think Rohan has identified the champions for the teams. Again, the same thing, right? So nothing changes. The recommended books. This is the master book. This is everything. This book contains everything demonstrated here, and it has a whole host of very systematically. He's made a science out of legacy code refactoring. So he used to work with Bob Martins, and his passion was just jumping into a legacy code base and making it deliver value. So that was what he used to do early on in his career for a good 20 years, right? And based on his patterns, he's identified Michael Feathers, right? So he's the god. That's pretty much the presentation, and if we will start the hands-on shortly, 11:30. We went overboard by 15 minutes here, but I think it's fine. I had fun. Hope you guys had fun too.
Thanks, this was interesting.
Yeah, we can hang up. You guys have any questions? Let me know. I'll be anyway. You can reach me over Teams, and we can during the hands-on. I'll be available, and if, I'll send out the details.
Cool. Thank you.
Okay. Thanks, David. Bye.
Bye.
Bye, Ken.